Hello viewers, in today's class we are going to discuss another important problem from integral inequalities. So in this session we'll prove this integral inequality in which we have to prove that the value of this integral 0 to pi by 2 sine 2x over x dx is greater than 4 over pi, right? So let us start and let us first take this integral as I. So we'll take I as 0 to pi by 2 sine 2x over x dx, right? So it means we have to show that the integral I is greater than 4 over pi, right? So now let us consider a function f of x is equal to sine x over x, right? Now see, in the integrand we have the function sine 2x over x, but here we are assuming the function f of x as sine x over x, right? And here we'll apply the concept of derivative and the concept of increasing and decreasing functions to show that this function f of x is a decreasing function. So let us consider fx is equal to sine x over x in the interval that is 0 to pi by 2. Now let us find out the derivative of f of x. So f prime of x is given by here in the denominator we have x square. We are applying the quotient rule here. So we have x, the derivative of sine x is cosine x, and then we have sine x and derivative of x is 1, and in the denominator we have x square. So here we can take cos x common in the numerator. So we have cos x, then we can write x minus sine x over cos x, and in the denominator we have x square. So we can now write it as cos x, and we have x minus tan x, and in the denominator we have x square, right? So the derivative of f of x is given by f prime of x, which is equal to this expression. So now let us consider the interval that is x belonging to 0 to pi by 2, right? And when we consider this interval, then from trigonometry we can easily conclude that x is always less than tan x whenever x belongs to this interval, that is 0 to pi by 2. So the value of tan x is always greater than x whenever we take x from 0 to pi by 2. It means when we are in the first quadrant, then tan x is greater than x. So this implies that x minus tan x is less than 0, right? So x minus tan x is negative or less than 0, and we can easily see that in the interval 0 to pi by 2, this cos x is always positive because we are in the first quadrant, and x square is obviously a positive quantity being a square, right? So cos x is positive, x square is positive, and x minus tan x is negative. So we can conclude that f prime of x is positive over positive times negative. So this is negative, right? It means it is less than 0. So the derivative is less than 0 or negative, and this suggests that this function f of x, which is sine x over x, is a decreasing function. So the function f of x is decreasing a function in the interval that is x greater than 0 and less than pi by 2, right? Because the slope is negative here. And let us now consider another definition of decreasing and increasing function, which can give us an important clue about how to prove this inequality. So if we consider two points x1 and x2 in the domain of f of x, right? And here x belongs to this interval. So if we consider x1 and x2, and if x1 is less than x2, then f of x1 should be greater than f of x2, right? This is the definition of decreasing function, right? So when x1 is less than x2, it implies that f of x1 should be greater than f of x2. And in the case of increasing function, we can write if x1 is less than x2, then f of x1 is also less than f of x2. So this is the case when the function is increasing, and this is the case when the function is decreasing. So we'll consider this one, right? So now let us take x1, this point as x, and this point, that is x2, as pi by 2, right? So we'll write x less than pi by 2. So for x1 we will write x, for x2 we will write pi by 2. Now applying this property, that is when x1 is less than x2, then f of x1 is greater than f of x2. So we can now write f of x is greater than f of pi by 2. Now f of x is sine x over x, right? And this is greater than f of pi by 2. So f of pi by 2 can be obtained from here by taking x is equal to pi by 2. So we have sine pi by 2 over pi by 2. Sine pi by 2 is sine 90 degrees, that is 1. And here we have pi by 2. So we have 2 over pi, right? So here we have 2 over pi. So now we'll utilize this inequality to get this one. So now let us multiply this inequality throughout by 2 cos x, right? Since x belongs to 0 to pi by 2, it means we are in the first quadrant. So in the first quadrant, cosine x is positive. So there is no harm in multiplying both sides of this inequality by 2 times of cosine x, right? So what we will get, we'll get 2 cos x, then here we have sine x over x, and here we have 2 over pi times 2 cos x, right? Now see, 2 cos x sine x is sine 2x. So this is the double angle formula for sine function. So 2 cos x sine x is sine 2x, and in the denominator we have x, and here we have 4 over pi cos of x, right? So now we have obtained this inequality. So now if we take sine 2x over x as some function, say g of x, and this function as h of x, right? So we have here g of x is greater than h of x, right? And whenever we have two functions, g of x and h of x, like this, and g of x and h of x are continuous functions, and here x belongs to the interval 0 to pi by 2, then there is an important inequality in definite integrals. So the inequality states that if gx is greater than h of x, and then we can write the integral a to b g of x dx is also greater than the integral a to b h of x dx, right? So whenever we have two functions, g of x and h of x, which are continuous in the interval, that is here the interval is given as 0 to pi by 2. So the integral of gx from a to b should also be greater than the integral of h of x from a to b. So here the value of a is 0 and the value of b is pi by 2. So now we can write 0 to pi by 2, and g of x is sine 2x over x. This is dx, and here we have 0 to pi by 2, and h of x is 4 over pi cos of x dx, right? So now this integral we can denote it by I, and I is greater than, here 4 upon pi can be taken outside the integral. We have 0 to pi by 2, and here we have cos of x dx, right? So we can find the value of this integral. So here we have the integral of cosine x is sine x, and limits are from 0 to pi by 2, right? So we have I greater than 4 by pi, and we have sine pi by 2 minus sine 0. So sine pi by 2 is 1, sine 0 is 0, so this is 1. So here we have 1 minus 0, so that is equal to 4 over pi, because 4 over pi times 1 is 4 over pi, right? So therefore I is greater than 4 over pi. So viewers, this is how we can prove this inequality, right? And here this integral which is I is greater than 4 by pi when x belongs to the interval that is 0 to pi by 2.